Okay, so what's up, guys? This is Akshay here, and let us continue with the next question of our, or let's say the last question of our bit manipulation. So it says decode XORed permutation. And before starting ahead, let me tell you, this is actually a good question, right? So let us read in the question. So there's an integer array perm that is the permutation of first and positive integers where n is always odd, right? It was encoded into another integer encoded that is length from n minus 1 such that encoded of y is given as like this. For example, 132, the encoded is 2 and 1. So how we are going from permutation to encoded is, so the first value here is the XOR of the first two values. Then the second value of encoded is the XOR of the second and third value, right? Given the encoded array return the original array perm. So we have to do some reverse engineering here. So permutation array is not given to you. Encoded is given. You need to return the permutation one, right? So let's do some reverse engineering. Let us analyze what is our need in this question, and then we can proceed ahead. So let us take this example. This is slightly bigger. So the permutation array given to you as 2, 4, 1, 5, and 3, right? And the decoded array, or say the encoded array, the first would be XOR of these two. So 4 XOR 2 is nothing but, so let us verify this as well in the meanwhile. So 4 XOR 2 is nothing but 0, 0 will give you 1. It will give you, okay, the same bits in the XOR returns 0, right? If this is flipped, 0 and 1 will give you 1. 1 and 0 will give you 1. So what is the value? 6. So that's for 6 here. Then again 4 XOR 1. So 1 0 0 and XOR 1. So it will give you 1, it will give you 0, and it will give you 1. So 1 0 1 is nothing but 5. So we have found the match, right? So let us not verify for rest of the cases. So 6, 5, 4 and 6. This 4 is nothing but the XOR of 1 and 5, right? And this 6 is nothing but the XOR of 5 and 6. So understand one, or observe one thing here is that you know that 0 XOR 1 is equals to 1. Let us define in terms of a variable. So I can say A XOR B is equals to C, and I can also say if I want to find B, then I can say B XOR C, and if I want to find A, I can say A XOR C. If you put the values here, verify it for yourselves. So A XOR B XOR C. So B was 1, right? So 1 XOR C here is 1, and B here is 0. So yeah, it follows, right? So this is the thing we need to take advantage of. Now, this is the first observation, you can say. Second observation is, using this observation, this is your input. This is your input. This is my output, right? So if I'm able to find my first number, let's say somehow I was able to get this first number, just the first number, then can I say, using this first number, right? Can I say, since I found my first number, I will put it in my output array. Then what can I say is, using this first number, I will XOR with 6 and I will get 4. I will XOR with 6 and I will get 4. You can see the reverse engineering happening, right? So let us verify this as well. So 6 is nothing but 1 1 0. If you XOR it, it would be 0 0 and 1 and 4. Voila, you got the answer. That's the 4, right? So that's the beauty, I can say. Again, since we have got this 4, I can do again one reverse engineering. I will XOR with 5 and I will get my next output, that is 1. Let us verify again. So 1 0 0 XOR with 5 will give you 0 1 as 1, 0 0 will give you 0 and 0. Definitely. Great, yeah. We got 1. Yay. So again do the reverse engineering. So 1 XOR 4 will give you 5, 5 XOR 6 will give you 3. Now what is my need? What is my need? I just need to find my first element of output, and this question would be solved. Now this question seems very easy, right? Or maybe we have converted this question from medium to easy now, right? How we can find the first element of our given output? Okay, we will leverage this property which is saying here that the permutation array is nothing but the permutation of first and positive integers. You can clearly see this is nothing but the first 10 positive integers, right? From 1 to 5, right? And how we can get this upper limit? That if it is the permutation of first 5 integers or first 6 integers, we will take help of our given array. Given array. The number here is 4. So definitely in this array, the values would be 5. Then only we get the adjacent XOR of the element and the value, and the encoded array has the size 4. If this permutation array size was 7, then I can say that if I do the adjacent element XOR, then the encoded array will have value length of 6. So again, we'll do a reverse engineering here. The 6 is given to me and I will find 7. The 4 is given to me, I can get 5, right? So my output array size, I can get it from the given array, that is encoded dot length plus 1, right? So, and I know that this is the permutation from 1 to this given encoded dot length. What is the value? It is 4, 5. So my output array I know is the permutation of 1 to 5, right? So what can I do here is, so let's just name this thing as A0, as A1, as A2, and then A3 and A4. And let us do again the reverse engineering. So what are the given elements here as? 2, 4, 1, 5 and 3, right? So I will have an explicit for loop going from I equals to 1 till I less than equals to n and I plus plus, right? And I will store the XOR of these numbers, right? So I will have, or let's say map it. So I will have the XOR of 1, 2, 3 XOR, 4 XOR and 5. I hope that's visible. Yes, that's visible. Let's just map it now. So 1 is present at A2, 2 is present at A0, 3 is present at A4, and 4 is present at A1, and 5 is present at A3. So definitely if I use this for loop, I will get the XOR of all the elements that is to be present in the output, right? So I think you are getting it, how we are doing the reverse engineering part here. Now I have got the output of all the elements that is to be present in my output array. I do not have this output array as of now with me. I have used this for loop to get that, right? Right. Now what else we will do? Is now we will take help of encoded array. So 6, 5, 4 and 6. And this was okay, so let's just go here. Let's use a different color. So this was our output array, right? And this is your encoded array. If I take the XOR from I equals to 1 and skip the element, like I'm talking about, take the XOR of 5 and then skip 1 and take the XOR of next element, again skip 1, take the XOR of next element. So what will happen? I'm actually taking 5 XOR 6. But what 5 is actually? 5 is the XOR of 4 and 1. It is the XOR of 4 and 1. And what this 6 is actually? It is XOR of 5 and 3. Right? Now let us map again with this 4, 1, 5, and 3. So 4 was actually A1. So let me write it A1 here. 1 was actually A2. Let me write A2 here. And 5 was actually A3. Let me write A3 here. And 3 was actually A4. Right? So for this thing, I can use a for loop like this. So for I equals to 1, I less than equals to n, I equals to I plus 2, and I can get the XOR. So I will get the XOR of, let's say I am storing it as a variable encoded, and I'll get the XOR of encoded XOR. The array name is encoded of I. So what I will have? I will have the XOR of A1, A2, A3, A4. Now, listen carefully. We have the XOR of this thing. We have the XOR of this thing, right? What are the values present here? We have the values of A1, A2, A3, A4. Here we have the XOR of values of A1, A2, A3, A4, and A0. If I do a XOR between this one and this two, can I get A0? Can I get A0? Think carefully. Yes, I can get it. right? Because why will I get it? Because A XOR A is always 0, right? So let me write it for you again. So A1 XOR A2 XOR A3 XOR A4, and what I am XORing with? A2, A0, A4, A1, and A3. So the same elements will cancel out. A3 will cancel out A3, A4 will cancel out A4, A1 will cancel out A1, A2 will cancel out A1. So what are the element left? A0. So we have found our A0, and that is it. Once we have found the A0, we will do a reverse engineering part. So this 2 is nothing but A0 here. We'll again run a for loop and we will get the order of these elements. Voila. So that was the beauty of this problem, and that is why I said this is actually a very good problem. Right? Now, your duty. First of all, please pause this video here, try to dry run these cases for some more test cases, and then move ahead with the coding section. So since I am teaching you here, since I'm explaining the code and everything, so let us now see the code. So first of all, we have int n storing the length of encoded array plus 1. That is, our output array would be the permutation of 1 till this inclusive n. Now we have a XOR of our permutation array. How we can do this? We can use this for loop and we can get the XOR of A0 to A n, let's say. Right here the n is 4, so that's why A0 to A4. That's what I have explained in the pseudocode, right? Then we have an encoded XOR 0, right? And then we have a for loop running from I equals to encode.length, and we have found the encoded XOR of all the particular elements in the encoded array, and we are doing I equals to I plus 2. That's the reason there, right? You understand the reason, right? Because we just want A1, A2, A3, and A4, and we not want A0, right? And that is why we have started from I equals to 1, skipping the next element and going to the other element, right, till we have reached the last element. So that was your step 2. Okay, what is the step 3? So we have finally found our A0, the first element. Now we'll do a reverse engineering part, and using this A0 we will get rest of the elements. Reason being here, if A XOR B equals to C, then definitely B can be obtained by A XOR C and A can be obtained by B XOR C. And that is what is happening in this last sentence. And at last we will say return answer. So yes, we have done this question. And congratulations to you guys if you're able to understand. I hope you were able to understand because I have explained my best. So yes, let us hit the submit button for this code. Before I just submitting, what is the time and space complexity? So we are using a for loop here. So O of n again here. So it would be and again O of n. So O of 3n, ignoring the constant, would be O of n. And what is the space complexity? We are not using any other space instead of some arrays. And if you ignore the return type space, then it would be O of 1, right? And what else? Let us see the C++. Okay, so that's the C++ code. Is the same we have done in Java in the dry run. So let me just scroll it through so you can see. And that's it. We have done the question, right? So few last thing that you can start and fork my DSL repository. All the source code is available here. And if you've understood the problem and the solution, the efficient approach, do like, share, and subscribe. And yes, till then, let us meet again in the next question. Till then, keep learning, keep growing. Bye-bye, and take care, guys.